Hello and good afternoon, people of YouTube. Today will be my first video on network automation. This video is more for my colleagues that I want to show what I'm doing from home, but if you take anything away from this, that would be amazing. So let's get started. Just to get the lay of the land in this video, I'm going to go over the apps and devices I will be using. So as you see, I have Visual Studio Code. This is my editor of choice for anything programming or networking related. Let's get rid of that. So here you can see a repository called CCIE_enterprise. So this video will be going over my CCIE enterprise journey. So I am taking the INE videos that are about 100 hours long, and as I go along, I want to document, blog, and make videos of everything I'm doing in the meantime. Mainly to show my fellow colleagues, people at work, and documenting, blogging, and talking about it really helps you take in what you're learning. So again, I have this repository, and all this is Ansible. Yes, Ansible. We will be talking about Ansible today in my Ansible repository. Here you can actually see my GNS3 network topology. This is the INE's CCIE version 4.5 and now 1.0 routing and switching or enterprise network diagram. So I just copied theirs, right, because I'm following along with their videos. As you can see, there's 10 devices in here. So for this video of network automation, the thing I am focusing on is showing people how to baseline all your routers in one time go. As we know, when we're taking these videos that are 10, 20, 30 hours long, we go over a lot of different routing subjects: ERGRP, BGP, OSPF, RIP, and then we move into switching, HSRP, and all these technologies. So here I'm going to show you how to quickly baseline your routers so that when you're following along and the video starts out with already cleared routers, even though you just finished the OSPF one and now you're moving to ERGRP, you don't have to go through every router and type no router OSPF or no router ERGRP for every single router. This would be a quick way with the click of a button to baseline all your routers. So let's get started. First, I want to show you my actual Ansible repository. So what do we have here? We have all my hosts, and these are the routers in that network diagram I showed you in GNS3. And all these hosts have a role. Their own role is what Ansible calls it. As you can see, this is every router's host name. And in these roles, I have three main folders. Here we're going to focus on this Jinja2 folder, or file, excuse me, and this main.yaml file. As you can probably already guess, this is just a template for building a router's configuration, its startup config or its running config. So all these roles have the unique baseline of all these routers' running configs. So if we just do a quick comparison between our Chandler R10 router and our Phoenix router, which is the DMVPN hub, we can see quite the difference in configuration. This is the beauty of actually organizing all your routers into their own role. So now every router has its own unique baseline. So what good are these roles? Well, here we'll go to my actual playbook, baseline.yaml. Here we can see two separate tasks per se. The first task is we're actually going to generate configuration files. You can see here at this roles keyword that we're going to execute the files in each of the folders under roles. This will generate a configuration, and it will be sent on our local host, so our local repository. And all those configs that we generate by running this playbook, we placed right here. As we can see, this is every single configuration for our routers. This is their baseline. So when I am going through INE's videos, I now have a baseline that I can use for the EIGRP, the OSPF, the BGP section, all the sections in the routing and switching. So let's look back at our VS Code. So what do we have in our configuration actually? We have IP addresses that will remain for the entire CCIE course in INE. And we have two applets. One applet we have here is baseline, which actually gets executed with an alias baseline. So I type in privileged exec mode baseline, and this applet will get run. This applet is getting rid of any routing process. And then it's copying a file from our flash, router.cfg, to our running config. So what is that doing? Well, once all this file is pushed, we do a copy running config to the flash. So once the baseline is pushed, immediately we get a good baseline stuck in our flash. So we can easily do this command right here. And now we have that good baseline always stored in our flash. Just something I do for a backup, let's say. So now that we have seen every router's baseline configuration, how do we actually send this baseline to the routers? Well, first thing we got to look at is our GNS3 topology. Here we have this NAT cloud. This NAT cloud has an IP address of 192.168.122.1. That is actually this laptop, this workstation that I'm working on's virtual IP address, and that is the default gateway out to the internet. So this NAT cloud is doing something Linux likes to call IP masquerading, which is essentially NAT. So any traffic sent here is going to be translated out to the internet from the source address 192.168.122.1, which is actually my laptop's IP address. So if we console into these routers, and we'll go to the router farthest away, and we ping the internet. Here we're pinging Google's DNS, we can actually reach out to the internet. Now, for anyone who's a network engineer, we know that NAT, or PAT in this instance, can take a number of devices on the inside network and reach the outside network. That is no problem. But let's get into this Boston router, the one actually doing NAT. And let's look at our Nat Translations. So let's send that ping again. And let's look at our Nat Translations. So we can see our inside global address is actually gig1/0 on this router. And our inside local is going to be the R10 router's loopback address. Okay, so that's good. All of our routers can reach the internet. So if I had a server out somewhere in the world, I should be able to baseline using this repository, right, from anywhere in the world. Well, it's not exactly that easy. This router, our Boston router, actually has to employ a technology. I should put NAT there, called port forwarding, which is essentially saying, hey, any device that wants to talk to 192.168.122.30 with a port of 23 is actually going to get sent to this router on this port. So why did I choose this port number and this IP address? Each IP address you see here is a router's loopback. And then this is the port of SSH. So all I want to do from the internet, from anywhere in the world, is be able to baseline these routers in my GNS3 topology. Ansible uses SSH to push a playbook to actually connect to Cisco routers. So let's go back to my repository. If I actually look at these hosts, each host has a corresponding port and the same IP address. This is essentially doing port forwarding on PAT from our R9 router here. And now we're able to actually SSH from the internet to my routers in GNS3. So now let's go to my AWX. So AWX is an open source project by Ansible to give a web-based GUI for all your playbooks. So what we're actually doing is taking this repo, uploading it, right, if I go to my source control button here, to a Git repository. My Git repository is hosted on GitLab. Sign in real quick. So this project, this repo right here, is actually what AWX is using for all my playbooks and my templates. And on another video, I'll show you actually how we do that, how we integrate AWX to Git. But for now, all I'm going to do is run this baseline. And what this is just that one playbook, baseline.yaml, based off this project, which is sourced from this Git repository. And I'm going to apply this playbook to this inventory, which is also based off this Git repo. So let's baseline all of our routers with a click of a button. I'm going to bring up R10 down here. And we're going to see a syslog message here, once this gets running, of our AWX actually connecting to this router. So here we generated all the configuration files. And now we're going to go ahead and push those configs we just generated to all these routers. And the first one we hit is R10. And as you can see here, we got configured from this IP address, which is also our AWX server. So with a click of a button, we're able to baseline all of our routers. And now, if I need to baseline my router and I'm in the CLI, I can execute that applet. And now all routing processes should die, as we see here of OSPF. And if I need to connect this router to the internet, I need to enable OSPF again. I could run another applet based off an alias that lets me do exactly that. So what is port forwarding on a Cisco iOS? Let's actually take a look at it. Here we can see I have a bunch of entries for a static NAT translation. This static NAT translation is actually telling the Boston router that when an outside source wants to talk to any of these devices on port 22, and these devices, these actual IP addresses are the loopbacks for all 10 of my routers, they have to come to this IP address with this port number. That's all that's saying. If I want to reach router 150 .1.7.7. Excuse me, let me get this out of the way. Then I have to come, and I want to reach it via SSH. Then I have to come to 192.168.122.30 on port 23. So why did we make this static NAT translation? We made this static NAT translation because Ansible uses SSH. So to actually send a configuration to employ a playbook and connect to Cisco iOS, we use SSH. So now let's go to AWX. AWX integrates with a lot of different source control management platforms. For this example, and for my network, AWX is being integrated with my GitLab repo. My GitLab repo is updated from my local repository on my local machine that we were looking at earlier on Visual Studio Code. And as we can see here, that every device mimics that static NAT entry. So when AWX creates a project and creates inventories and then templates based off those projects and inventories, as we can see here, CCIE Enterprise Inventory and Project, that's how we are actually connecting to the routers in my GNS3 topology. It's all based off this Git source control manager. So now this template is actually just running the baseline.yaml playbook. And that playbook is a part of this project and is getting ran against this inventory, which again is all source controlled from my GitLab repo right here, which is uploaded from my local source on VS Code on my local machine. So now let's baseline all of our routers with the click of a button. I'm going to drag R10's CLI over here so we can get a syslog message and actually see this AWX actually connecting and making a change to my router, and we will get a syslog message appearing on the screen. So let's hit that rocket launcher. Let's see this baseline happen. So again, all we're doing right now is running that playbook, which is source controlled from my GitLab repo up here. Again, this can take some time. This AWX instance is actually on Docker on my own virtual machine on the very workstation that we're using right now. So here we generated the configs, and now we're pushing those configs to all the devices. As we can see here, there was a configuration change to this router. So let's go back to our GNS3 topology. Now let's run those applets and see if our baseline was actually successful. So if I type in baseline, that applet should run, and all routing processes should end, as we see here. Now if I want this router to talk to the internet again, to be able to reach out, I'm going to run my internet applet based on this alias, which is just internet. And we can see my OSPF process coming back up now. I hope this video has helped anyone watching. Mainly I made this just to show my colleagues what I'm doing at home and maybe give them some inspiration on how to automate their networks at home. So thank you for joining me, and I hope you have a good night.